Welcome to adding and subtracting with radicals. So this is a building off of when we were simplifying before the radicals. So you still have to be able to simplify your radicals. We're going to identify radicals that have the same radicand. Remember, the radicand is the number underneath the radical. You can only combine radicals with the same radicand because they are like terms. So you cannot combine unlike terms. For common radicals, you're going to add or subtract the coefficient, which means the number in front, and keep the common radical the same. That means do not change whatever's under the radical. So let's take a look at our example here. Simplify all radicals. Okay, when I'm looking at these, let's see if these will break down. 20, I think 2 times 10, I could have done 4 times 5. Remember, we can use different pairs and end up with the same answer at the end. 2 times 10, 2 is prime. 10 will break down again to 2 times 5. Okay. So I have a coefficient out front. I'm going to bring it down, and it's going to multiply to whatever I bring out from under the radical. I have a pair of 2's right here. That means a 2 will come out, and I have a 5 right here who has to remain inside. Negative 2 times 2 is negative 4, and then I have root 5. Root 5 won't break down any further. I just found that out because that's really just 1 times 5. 5 is prime. Nothing's going to happen. So I'm going to bring it down because I wasn't able to change it in any way. It says identify the radicals that have the same radicand. Square root of 5, square root of 5. You can only combine radicals that have the same radicand because they're like terms. Add or subtract the coefficients. So what that means is negative 4 minus 2. If I am negative 4 and I go 2 more negative, I end up with negative 6 and then keep the common radical the same, square root 5. All right, so hopefully that's not too complicated. We're going to try several of them here to help you with it. Okay, so simplify all radicals. 6 is 2 times 3. Neither one of those can break down any further. So I have no pairs. So 6 is as simple as it can go, and I've got the square root of 6 and square root of 6, so they have the same radicand. So I'm only going to look at their coefficients. I have a 3 and a negative 2. Well, what is 3 minus 2? Is 1, and keep the radicand the same. You might see it written just like this without the 1 in front, but it's not wrong to write the 1. It might help you kind of remember what you're doing. All right, let's look at number 2. Look at their radicands. Is 5 a prime number? It is. It's 1 times 5. It won't break down any further, so we're going to leave it. These guys have the same radicands, so we're only going to look at the coefficients in front. I have 2 plus 2, which gives me 4, and then keep the radicand the same. All right, so of course I started easier. I'm going to make it a little bit harder for you now. We're going to follow the same steps. What I'm doing, what I'm talking myself through each time is exactly the same. Simplify all radicals. All right, so let's take a look. Does 15 break down? It breaks down to 3 times 5. But 3 and 5 are both prime, so I can't break them down any further, and there's no pair. So we're going to keep the square root of 15. I have this coefficient. Remember this guy, he's negative 6. He's going to multiply to anything that comes out of anything can come out. So I need a little bit of room. We're looking at the square root of 50, which I think 5 times 10. 10 will break down again to 2 times 5. Now I'm at all prime numbers. When I look, I have a pair of 5's right there. So that means I can bring a 5 out. It's got to multiply to that coefficient. But this 2 right here has got to remain underneath. So we have negative 6 times 5, which gives me negative 30. And I have the square root of 2. These radicands are not the same. So we're actually done right here. That is our answer. That's as simple as this is going to get. And by simple, I don't mean easy. I mean it won't break down any further. All right, let's try number 4. 32. Oh, I'm sure that can break down. So we got 4 times 8 is 32. 4 can break down again. 2 times 2. 8 can break down to 2 times 4. 2's are prime, so they're not going to break down any further, but that 4 breaks down to 2 times 2. All right. If you watched one of my previous videos, you'll notice I cross out things that I've rewritten to help me kind of concentrate here. So I have a coefficient of a 2 that's going to come down. I can't lose him. He's going to multiply to anything else I take out. I have a pair of 2's, so I'm going to bring one of those out. I have another pair of 2's, so I'm going to bring one of those out. And then I have that guy. He has no pairs, and if there's no pairs, they're going to stay under the radical. So 2 times 2 times 2 gives me 8 root 2. I got it simplified down. That is only half of this. So let's try the other half. I have a coefficient of -3. It's going to multiply to anything that comes out. Let's see what does. So 18, off the top of my head, I came up with 2 times 9. 2 is prime. 9 breaks down to 3 times 3. I have a pair of 3's, which means the 3 can come down. And then there's this 2 right here. He's all alone, so he has to remain under the radical. -3 times 3 is -9 root 2. And I'm still not done, because when I'm looking, they have the same radicand. That means I can combine them. When they have the same radicand, look only at our coefficients out front. I have 8 minus 9, which is -1, and then you keep the radicand. All right, that was a good one. 2 more. This might be a good place to stop. Try it without me and see what happens. Come back and check your answers. All right, I have a coefficient. I'm going to bring him down before I start because I know I don't want to lose him. He's going to multiply to anything that comes out. So 160, right off the top of my head, I see 16 times 10. 16 breaks down to 4 times 4. Once you've got a pair, you don't have to keep going down to the prime numbers. We can stop right here with that pair. I'm not going to break them down anymore because I have a pair of 4's, so I can bring one out. The 10 could break down again to 2 times 5, but neither one of these are going to have a pair, so they're going to remain under the radical and be multiplied back together. So this is going to all simplify down to -16 square root 10. Now let's take a look at the other one. I have a coefficient there of -2. He's going to multiply to whatever else I bring down. 90, I think 9 times 10. 9 is 3 times 3. 10 is 2 times 5. I have a pair of 3's, so I'm going to bring them to the outside. Both of these guys are alone, so they go back inside to be remultiplied back together. So I have -2 times 3, which is -6. 2 times 5 is 10. Their radicands are the same. So I have -16 minus 6, which is -22. Keep the radicand root 10. All right, one last one. If you haven't done one without me yet, try this one all on your own and come back and check your work. So I'm going to show you my whole process. There's my coefficient. I'm going to bring them down so I don't forget them. 45, I came up with 9 times 5. Yeah. 5 is prime. It won't break down, but 9 becomes 3 times 3. I have a pair of 3's, which means one comes to the outside. This 5 is alone, so he's going to stay inside. So I end up with 12 root 5. Let's look at our other one. Bring my coefficient out of 3. It's going to multiply to whatever else I bring out. 245. Well, it ends in 5, so I know it's divisible by 5. So let's go 245 divided by 5, 49. 5 times 49. 5 is prime, so we're done there. 49, that's one of our perfect squares that I was reminding you of in the last video. 7 times 7. I have a pair of 7's, so that means 1 7 comes out. This 5 has no pairs. That means he goes back underneath the radical. He's got no one else to multiply to under there. 3 times 7 is 21. It's a positive 21, so I'm going to say plus 21 root 5. My radicands are the same, so I'm just going to look at the coefficients. 21 and 12 is 33 root 5 will be your final answer. Good luck with your practice. Come back and watch the video if you have trouble.